moving linear combination is equal to 0. It is true only when the scalars ai are all equal to 0. Okay, so that's a definition of linearly independent. For the spanning, consider a set of vectors v1, v2, all the way to vn. The set of all linear combination of this set is called the span. Recall, a linear combination is in the form of C1 times V1 plus C2 times V2 all the way to Cn times Bn, where each Ci is a real number scalar. So, may tatabag scalar, then multiply sa vectors. Okay, so let's have an example 1. So, let V is equal to R3. The vectors 1, 0, 0, 0, 1, 0, 0, 0, 1 form a basis for R cubed. It is called the natural basis or standard basis for R3. Okay, ito daw ang vectors na ito, natural basis or standard basis for R3. Take note, di ba? To call it a basis, dapat daw span daw siya and then linearly independent. Now, let's show it first if it is linearly independent. So, di ba? We are going to multiply a scalar a sub 1 with the vector 1, 0, 0. Wala. Nawala ko, classmate.
Wala man. Oh, nama. Hello. Madungog
Yes,
ko?
sir.
Yes, sir. Madungog ka, sir.
How about me?
Madungog ka, sir.
Classmates?
Yes, ma'am. Yes, madungog ka, ma'am.
Okay
Matinaw.
I'll continue.
Yes, sir. Madungog, sir.
Okay, shall I continue? Yes, Sir Giovanni, madungog ka po. Continue lang ko. Okay. Okay, so let's show it first if it is linearly independent. Diba ang condition? Linearly independent, tapos spanning daw siya. So, a sub 1, multiply na sa given vector 1, 0, 0, plus a sub 2 times 0, 1, 0.
Junil boy, tayo na tayo.
A sub 3 is equal to 0, 0. A sub 3 times 0, 0, 1 is equal to a 0 vector daw. Okay? So, it's very obvious here. We found out that by multiplying that, so that is a sub 1 times 0, a sub 1, 0, 0, plus a sub 2 times 3, and that is 0, a sub 2, 0. Then a sub 3 times ka na siya, these vectors, and that is 0, 0, a sub 3 is equal to a 0 vector. So, di ba? It is obvious that a sub 1 is equal to 0, a sub 2 is equal to 0, and a sub 3 is equal to 0. Since all scalars are 0, then it is linearly independent. Okay? So, na-check na ito yung linearly independent. How about the spanning? So, solution for the spanning. So, let's say a sub 1, it times siya sa vectors 1, 0, 0, plus a sub 2 times 0, 1, 0. Then a sub 3 times 0, 0, 1. Dapat daw may equal na siya sa A, B, and C. Okay? Maka-form na gapon siya sa R3. Okay? So, that's spanning. So, after we multiply it, wait sa na-out ko. Abutan sa ito si Sir, ha?
Okay, hello?
Hello, sir.
Hello, sir.
Madungog ka?
Yes, sir.
Yes, sir. Madungog po,
Sige,
sir.
sorry for the inconvenience because I lost my connection. Okay, you may continue now.
Okay po. Okay, so a sub 1 times this vector, so ito yung a sub 1, 0, 0, then a sub 2 times the vector 0, 1, 0, and that is 0, a sub 2, a sub 2, then 0. Then a sub 3 times 0, 0, 1, and that is 0, 0, a sub 3 is equal to a, b, and c. So therefore, okay, we found out that a sub 1 is equal to a sub 2 is equal to b, and a sub 3 is equal to e. So therefore, these vectors, diba, it spans R3. So since it spans R3, at the same time, this given vectors is linearly independent, so nasatisfy niya ang duha ka condition, so we can say that this form a basis for R cubed. Okay? That is example 1. We have proved that this is linearly independent, at the same time it spans B, so therefore it is a basis for R3. Okay? Another one is example 2. We are going to show that the set S is equal to t squared plus 1, t minus 1, 2t plus 2 is a basis for the vector space P2. Okay, so again, we're going to show it that it is linearly independent and also it spans B, sorry. Okay, so that is A times t squared plus bt plus c. But this is in a standard form, or shall I say in a polynomial with a degree of 2. So these are the polynomials. The concept of spanning is that we're gonna look for the value of the scalars. So we multiply, or say distribute the a1 to the given polynomial. So it's a1 times t squared, so ito yun siya. And then this is a1 plus a2t minus a sub 2 plus multiply this, and that is 2a sub 3, then t plus 2a sub 3, 2a sub 3. Okay? Next, we're gonna regroup it according to their degree of polynomial. Since we only have t squared here, so dyan lang siya. And then the t, ito, as well as this one. So, t, and that is a sub 2 plus 2a sub, yung numbers only or the scalars only, that's a sub 1, then negative a sub 2 plus 2a sub 3. So, multiply it by 1, or let's say by identity. So, we found out that a sub 1 is equal to a sub 2 plus 2a sub 3 is equal to b, and a sub 1 minus a sub 2 plus 2a sub 3 is equal to c. Okay? Now, next. Okay, from this, we're gonna solve for the scalars. Okay, mo man yung scalar, di ba? The a sub 1, a sub 2, and a sub 3. So, we get a sub 1 is equal to a sub 2 is equal to a plus b minus c over 2, and then a sub 3 is equal to c plus b minus a over 4. Since we get the scalars of this, so we can say that S spans B. If you're asking about how do I get this a sub 1, a sub 2, and a sub 3, actually medyo mahaba yung process niya. Ito yon. So from these conditions, katong gisolve to ganina, coming from this, kini, coming ani, we solve for a sub 1 and a sub 2. So this is a sub 1, automatic is a sub 1 man daw is equal to a. And then, tapos, isolve sa naku una ang a sub 3. So to get the a sub 3, is ito yan siya, diri ko nag-base actually. So, 2a sub 3 is equal to a sub 1, negative a sub 1, plus 2a sub 2. So, I get the value for a sub 3. Okay? Then, for the a sub 2, since meron akong value ni a sub 1 at saka ni a sub 2, so for the a sub 2, that is, yan siya, from E, lipat ko lang itong si 2a sub 3 dito sa kabila, and then also for the a sub 2. So this is the solution for the scalars a sub 1, a sub 2, and a sub 3.
Okay, so that's why
Okay?
it's called linearly dependent. Okay.
So first,
Okay,
doon
okay.
sa siya pag-span. So let's say, suppose that A is equal to 2, B is equal to 6, and C is equal to 13. So we can for the scalars from the previous computation, di ba? A sub 1 is equal to A. So which ang A man daw ay 2, so therefore A sub 1 is equal to 2, and then ang A sub 2 man daw ay A plus B minus C over 2, so 5 over 2. So that is A sub 2. Then A sub 3, just substitute 13 plus 6 minus 2 is equal to 17 over 4. So, pag i-multiply na natin na siya, we station, debit mo lang yan, ito, as T. And then, under siya sa P2. So, therefore, this S spans P2. Okay? So, we have shown already na mas-span siya. How about the linearly independent?
Linear independence, no?
Yes po.
Because there are two. So the point of Mama Tinao is that no matter what vector you will provide from P2, you can always find an A1, an A2, an A3 such that that vector becomes a linear combination, correct?
Yes po.
By setting A1 equal to A2 equal to A plus B minus C over 2, and A3 is C. So it is
Okay po.
a spanning set.
Okay. For the independent, so to show that S is linearly independent, then we form, okay? So we equate this one into 0. So same pa rin, we will solve for the atong i-group. A sub 2, alam lang ito, and then so we only have T squared here, tapos we only have 3 at saka yan. So that's why A sub 2 and 2A sub 3. And tapos combine all data times 1. So is equal to 0. So this can hold 1 is equal to 0. A sub 2 plus 2A sub 3 is equal to 0. And then C is equal to 0. Okay? We're not yet done. So, form right? So, ato na siya row echelon form until such time, let's say, ito na
Mama
siya
Tinao, Mama Tinao. Actually, there is no need for row echelon form anymore. Kay taas na siya, no? Klaro naman siya, no? Nga kung A sub 1 equal to 0, ang A sub... okay. Abin ako, like A sub 1. Sige, continue. Sorry.
Okay po. So, this is minus na lang. This is actually the operation, the row 1 minus row 3. Lagay mo yung answer sa row 3, so na 0. Yeah. And then, our goal is 0 na put ni. So, our operation, si row 2, i-minus daw ni mo sa row 3, lagay sa row 3. So, ito yon. Tapos, ito daw, is, i-1 sa daw natin this one, i-1, anyway, itong 4, multiplying by 1/4. So, that is 1/4 I mean by multiplied by 1/4, yung answer ilagay daw sa 3. And then, ang next goal is 0 daw din siya. So, which is, our operation is, the new R3, i-multiply mo by -2, i-plus mo si R2, ilagay mo yung sagot sa R2. So, this becomes a row echelon form. So, na 0, 0 na yung last row, yung 0 vector na. So, we found out that A sub 1, A sub 2, and A sub 3 are all 0, then it is linearly independent. So thus, since it is linearly independent, ito, and then mas span mo siya, so therefore, it is a basis for P2. Okay, next. So we have the example 3. Show that the set S, B1, B2, and B3, and B4, where the B1 is equal to 1, 0, 1, 0, B2 is 0, 1, -1, and 2, B3 is 0, 2, 2, 1, and B4 is equal to 1, 0, 0, 1. Is a basis for R4. Now, okay, so first, again, dapat ang vector niya is all are 0. So, to show that S is linearly independent, we form the equation into this. A sub 1 times B1 A sub 2 times B2 plus A sub 3 times B plus sub 4 times B4 by substitute medyo on the previous idea. So first, ato sa nigi 0 echelon form, and 0 by 1 minus R4 is equal to R4. Lagay answer na, lagay sa R4. And then, ang next goal na to is, kini siya, mahimo daw ng 0. So, ang operation natin, 2R2 minus twice of R2, i-minus mo siya sa R3, the answer ilagay sa R3. So, ito, ang answer daw, ilagay daw dyan. Our next goal is make it positive 1, di ba? So, ang R3 multiplied by -1/4, ilagay daw sa R3. So, yan siya. And then, the R3 ang ginamin dire is the new R3. So, this is operation. So, nahimo na siyang 0, 0. And then, the goal is to make it 1. Itong si 1/4 by multiplying it row 4 by 4. And then, rest of the operation, ito yon. So, nahimo na siyang 0, 0. Okay? So, that 8. Okay? So, therefore, linearly independent daw siya. How about this? So, to show that S spans R4, we let B is equal to A, B, C, and D. Be any vector in R4. We now seek a constant A1, A2, and A sub 3, and A sub 4 such that pag i-multiply daw nato sa kada vector, it will give us another vector na mo-satisfy siya sa kinin daw ng mga conditions. So, ang goal actually sa spanning is mangita ta og value is scalars, kining A sub 1, A sub 2, and A sub 3 in terms of the other variable. So, isa siya. Shall I say this? So, ang goal na ito, di ba? From convert to siya into an augmented matrix such that ang sa last, kasi tawagan yun sa kini siya, oh. May mo siyang A, B, C, sub 1, A sub 2, A sub 2, ay A sub 1, A sub 2, A sub 3, and A sub 4, such that, pag i-multiply na nato, mugawas daw siya diri na A, B, C. Okay, so ang goal na ko actually is, dito is as is lang na mga A, B, C, and ito, tsaka 1. Or ang sagot daw is lagay sa row 4. So let's say 1 minus 1, that is 0. How about A minus D? Kaya naman, row 1 minus row 4. So A minus D, ito yun. Okay, wala lang ko nag-set of any numbers, any values for this variable. Kaya ang goal man nato is to compute for
Dami ang no?
terms of till such time maka-row echelon form ko, and then maka-come up simply to A and A4. So I come up with A sub 1 is equal to 4B minus C minus 3D is 1. Basta ang result sa row echelon form ni gawas ang A1 daw ka na. And then A2 is this one, A3, and then A4. Okay?
Okay.
So pag span, so this is actually the spanning na. So pag akong i-counter check if tama ba, so I'll let any values A, B, C, and D. So let's say A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. So pag ako i-substitute daw diri, gawas ng A1 is equal to next 10, A2 is equal to next 12, and A4 is equal to 11. Now, pag i-multiply ko down ito sa mga given vectors,
Now, you form a linear combination using those scalars, di ba?
Kung gawa na ang kining A is equal to 1, di ba? Muna ganina, hindi siya i-multiply na nato sa 7, ang sa A2, which is negative 12, then ang A siya sa A3, and then this one, i-multiply siya sa A4, which is 11, di ba? Ang isa pa na, let's say, negative 7 times 1 plus 0 plus A is 1. So, di ba ang 1 is 0, negative 12 minus A plus 22, the result, and then this is 0, negative 24 plus 16 plus 11, the result is 3. Negative 7 plus 0 plus 0 plus 11, the answer is 4. So therefore, we have proved that the vectors, kini siya, V1, say, S span okay. So that's the end for now of my report. Example 1, 2, and 3. I'll be to discuss about the sorry. So now we'll continue discussing about examples 4 and 5. I'll be back with you later po.
Thank you so much, Miss Matina or Ma'am Matina, for the very informative presentation. And so the next example will be here, the presentation.
Reporters, don't forget to provide a screenshot for every question.
Okay lang mga itong PowerPoint natin, no?
I-post that later sa itong gusto for documentation.
Okay po.
Okay po, sir. Noted po, sir. Okay, so I will be discussing first the examples. We have the base any vector v1 to vn in the following two conditions should be linearly independent and S spans V. Another thing that we need to recall is we have the theorem 4.7. So the n only if one of the vectors Vj where j is greater than or equal to 2 is a linear combination that basically one of the vectors Vj is Vj minus 1. Another thing that we need is called finite dimensional. If there is a finite subset of V that is a basis of 4.
Ikuan na Mr. Sir Kampanya.
Yes po, sir.
Actually, pwede na rin mo ibutang sa later on pag-define mo sa dimension, no?
Okay po, sir. Sige.
Okay?
Oh, sir, a minute po, sir. Example 4. Example 4, where the set W of 2 by 2 matrix with trace equal to 0 or it 0 1 0 0. The V2 or vector 2 is a 0 0 1 0, and then V3 is 1 0 0 negative 1 is a basis is a 4.
Sir Kampanya.
Yes po, sir.
I think it cannot work because the set of all 2 by 2 matrices is the set of the dimension of the set of all 2 by 2 matrices is equal to 4. Correct?
Yes po, sir. Yes.
And this is composed only of 3. Therefore, it's clear na siya daw. Okay, sorry, Mr. Kampanya. Sir Kampanya, naman dito yung trace, no? What is meant by trace?
Trace po, sir. Yes po.
What is
No,
meant
sir.
by trace?
Ano Opo, sir.
of a matrix?
Sa ano sir, makita siya sir within the ano sir, the set of the vector. So makita siya within sa set sa vector sir.
I think the trace of a matrix is the it is the sum of the sum of elements on the main diagonal of A.
Yes po sir.
For example, katong
Okay, sir.
ganina.
Okay sir.
Katong ganina.
Should
Asa tong ganina?
i-present ako ni ano sir, video sir. Wait lang sir.
I-define sa ang trace kay matingala. For example, kanang plus 0, 0 man. Sakto? Kanang V2 o zero gihapon ang
Yes po sir.
iyang trace because kanawa ang iyang main diagonal 0 plus 0. 0. Then kanang 3, B3, ang trace ana niya is 1 plus negative 1, that is 0. So sakto din imong wala ko nabasa, the set of is a subspace of M22.
Was 0, 1, 0, 0, and then vector 2 with A2, 0, 0, times the vector 2, 0, 0, 1, 0, and then A3, 1 times the vector A1, 0, 0, negative 1, which is equal to the vector, which is negative 0, and then A1, 0, 0, plus the 0, 0, A2, and then 0, plus we have A3, then 0, 0, and then negative A3. It's equal to
Okay.
A, B, C, negative A. And then we get here A3, A1, A2, negative A3 is equal to the vector A, B, C, negative A.
Okay.
So we have again the A3, A1, A2, negative A3 is equal to the vector A, B, C, negative A. Then we get this. So just to write again, we have A3, A1, A2, the negative A3 is equal to A, B, and then C, the negative A. So to equate,
Ano ginang
or
negative
equating
yun na sa
them
imo
will
sir
give
kampanya?
us
Sir kampanya? Sir kampanya? Ngano gani ang representation sa imong V is A, B, C, negative A?
Ito po sir, galing sa ano po sir, sa given. So sa vector 1 po sir is 0, 1, 0, 0. So that's the B.
No. My question is why nga ang representation sa imong V is A, negative A, B, C. Nganong negative A man gyud nga dili man ka maka-generalize?
Galing po siya dito sir. Sorry po sir.
Why can you not generalize?
Assigned ano lang po sir, variable.
No. The reason for that, Sir Campania, is that you are not looking at the basis of the whole vector space of M22.
Subspace lang po sir.
You are only looking at the basis for the subspace of all 2 by 2 matrices with trace equal to 0. So kano saman siya mahimo ang trace niya kung equal to 0? Kung di ba unsay pasabot sa trace? Sa trace sa matrix? Hatagin ako kung matrix example sir kampanya makasulat ka 5432. Sige daw. Pagsulat ka sir kampanya,
Sige po, sir.
masun makasulat ka.
Okay
So,
lang po,
matingala
sir.
niya sa nga
Okay, sir. Wait lang po, sir.
maka-write ka.
Opo, sir. Wait lang po, sir.
Sige daw.
I-stop sharing ko muna natin, sir. Yung sulatan.
Kay matingala sa ano nag dili man siya general representation sa matrix. Subspace naman gud siya. Trace sa matrix. For example, kung ang iyang nasa yang main diagonal is 5, 4, pila ang imong trace?
9, sir, 9.
9. 9, that's why.
Which is not equal to 0.
That's why kung ang imong kung ang imong matrix is di ba, ma-prove man nato nga ang katong collection sa 2x2 matrices nga ang trace niya is 0, maka-form to siya og subspace. So therefore, kung A ang imuhang A11, kinahanglan i-negative ni A nimo ang A22 because pag-add nimo mahimo siya 0. Are you with me?
Yes, sir.
Okay, that's what A negative A.
Yes, sir.
That's why it is A negative A. Kaya para pag-add mo sa main diagonal, kung ang imo ang A sub 11 entry, A, butangan yun mo og negative A dito sa imong A sub 22 entry. Kaya para pag-sum nimo ang trace niya, mahimo nga 0. Okay? That's why ang iyang representation, unsa itong representation nimo sa imong V, Mr. Campanya? A negative A, B, C.
Yes po, sir. A, B, C, negative A.
A, B, A, B, C, negative A. Correct?
Yes po, sir.
Okay, okay. Sige, continue.
Then, we get this. So just to write again, we have A3, A1, A2, the negative A3 is equal to A, B, and then C, the negative A. So to equate or equating them will give us A is A1 is equal to B. So A1 is equal to B. So we are doing equating them, or we are equating them. So A2 is equal to C, and then A3 is equal to A. Thus, negative A3 is equal to negative A. So S now spans W. So we have already you get that one of the conditions of the basis, so which is to span. Now substituting the vector to a zero vector, so we have A, B, C, negative A will be 0, 0, 0, 0. Which then A is equal to A1 is equal to 0, A2 is equal to 0, A3 is equal to 0, which also means that A1 is equal to A2 is equal to A3 is equal to is equal to 0. So this means that we have proven, or we have shown that set S is a basis for W, since it is also linearly independent, since all its values is equal to the scalar 0. So it's corresponding. So if we replace the vector again by the zero matrix.
Excuse me, classmate, sir.
Yes.
Pwede ka mo transfer sa other link kay ang nahatag na ko na link. Quick trial lang na ako. So we will end this call 8 minutes from now.
Link,
Pwede ka mo transfer sa other link po.
Okay.
I'll send the link.
Okay.
Okay.
Yes po. Pag-provide po ako, sir.
Sige.
Thank you. Bye.
Nag-provide na? Okay na?
Ako, sir.
Okay, let's continue.
Now, another example is we have this one. So we are going to find a basis for the subspace V of polynomial or quadratic polynomial consisting of all vectors of the form at squared plus bt plus c, where c is equal to a minus v. So this is already under polynomial by quadratic polynomial. Now we are going to find a basis, or at least one basis, for quadratic polynomial. So vector of P2, so we have AT squared plus BT plus C, where again C is equal to A minus B. That means we can write this one as A T squared and then plus BT plus A minus B. Which can be then rewritten into. So this one now can also be written into A so A times the T squared plus A sorry sir, erratum. Ano po yan siya sir? Dapat A times T squared plus 1 po pala siya. Hindi T squared plus A. Then we get T squared plus A and then T minus 1, which are of course the vectors. So T squared plus A and then T minus 1. Which means that these vectors or the vectors span V. Moreover, these vectors are linearly independent because neither one is a multiple of the other. So this conclusion could also be reached by writing the equation into this form, where A is A sub 1 and then times quantity T squared plus 1 plus the B, which is A sub vector. Or that means A sub A1 T squared plus A2 T plus the difference of A1 and A2. So we must have A1 equal to 0 and A2 equal to 0. Now we have now the theorem for point. Okay, sir. So that ends my presentation as of the moment. So I'll give the floor to Ms. Matina or Ma'am Matina for the discussion of theorem 4.8 before I proceed with theorem 4.9.
Okay, thank you, Sir Janelle, for the, Okay, so let me continue my presentation on theorem 4.8. So V1, V2 all the way to Vn is a basis for a vector space V. Then every vector in V combination of the vectors in S. Okay, Just correct me if I'm wrong in my proof. Okay. I'm not also confident in my proof. So, basis for a vector space B. So, therefore, pag basis siya, so it must be linearly independent at span, di ba? However, since, di ba, sir? So, it says here, pag basis siya, so meaning to say, nakaspan na siya. So, we, shall say this. So, ang proof is, first, every vector in B can be written as a linear combination of the vectors in S because S spans B. Okay?
Oh, that is correct.
Okay, so B,
Nakaspan naman siya.
nakaspan na.
Basis naman siya mamatinaw.
Yes po, basis ang
Basis naman siya. So, spanning set na siya dito. So, bisan kinsa nga vectors ang imong kuhaon dito, ma-express na dayon siya as a linear combination of the vectors in S. Sakto?
yes po.
Mara na yung masakit niya. Okay.
Okay, so we have
Sige.
this one, a vector span daw niyan ano yung B, and then another span na po which is B1 times B1 plus B2 times B2 all the way to Bn times Bn. Now take,
No. Na matinaw, sayop ang imuhang pag, no? Murag medyo na kuan gamay ang imong proof, no? Murag na gamay nga, tawag ni ini,
incorrect.
hole. Na hole gamay.
Okay po.
Pasabot nimo ana mamatinaw isingon ani. Tungod kay ang V kay kuan man siya kanang
Ata.
spanning set man siya, ma-express siya sa as linear combination. Butang pa lang naapay lain nga linear combination ang V. Mo na ni gamit ka diri og B1, B2, up to Bn. Nakuha nimo?
Yes po, sir. Oo.
Ay ang imo manong purpose diri is ipakita nga isa ra gyud ang iyang linear combination.
Yes po.
Dili na nimo pwede siya ma-write as another linear combination. So therefore, suppose that there is another linear combination.
Mm-mm.
Okay, of V. So mo na kulang ang imong proof diri, no?
Okay.
Wala ka. Let V be equal to A1 V1, A2 V2, and to AN Vn. Suppose that there is another linear combination for V.
Okay po.
So, ipakita nimo karon nga ang A1 equal sa B1, ang A2 equal sa B2, until AN equal to Bn. Di ba mo ni purpose nimo dire?
Yes po, sir. Oo.
Okay. So kulang lang ka dinig. And suppose that there is another linear combination for V. Okay?
Kasi po, so suppose that we have another linear combination which is B is equal to B1 times B1 plus B2 times B2 all the way to Bn times Bn.
Okay.
Wait lang. Sir, naghang ang computer ko.
Okay lang.
Sir, naghang yun siya, sir.
Sige lang. Ipalungasa daw siya, palungasa siya.
Sige pa, sir, ha? Sorry for the technical difficulties. Um, sorry. Times B1 times B1 plus B2 times B2 all the way to Bn times Bn, we must show that A sub I is equal to Bi, or I is equal to 1 to all the way to n. Then we have, okay, pag isubtract natin ito, di ba, this is first linear combination, and then we have another linear combination. Pag isubtract natin ito, this is equal, di ba? So that becomes B1 and B minus B, di ba, that is equal to 0. And we can
Always emphasize, Mama Tinaw, ha, it is a zero vector.
Yes, po.
Not the zero
We have
scalar, ha?
vector B and then minus vector B. So that would result to a zero vector. Okay? So factor of this, diba? A sub 1 times B1 minus B1 times B1. So diba? We can factor out this one into A sub 1 minus B times 1, B minus B1 times B1. So this is, factor out. Oh, that is the same also as A sub 2 minus B2. Pag subtract mo yan, all the way to AM, AN times BN, then minus mo yan sa BN times BN. So, factor mo yan. And that is, since S is linearly independent, so weak daw sila tanan direct, A sub 1 minus B sub 1, then A sub 2 minus B sub 2 are all equal to 0. Okay, so we have proved that there is only one of a vector in S.
Okay.
That's
So, kung kasabot kung nag-create ka ng scalar atong linear combination, pareho rin gapon atong original. Because AI is equal to BI. Sakto? Because if AI minus
Yes.
BI is equal to 0, meaning ang AI nimo equal to BI. Scalar man na.
Yes po,
Okay? So, kung nag-create ka laing linear combination, mapugos jud ka nga katong imong AI equal na to siya sa BI. So, therefore, ang B nimo nga ang representation sa imong B is unique. Okay?
Yes po. That's the end of my presentation, and thank you po for listening. Sir Janelle pa na po.
Thank you, ma'am. Be a set of non-zero vectors, v1 to vn, in a vector space of V, and suppose that W is equal to span S. Then some subset of S is a basis for W. So sum of the subset of S can be a basis for W.
Hello, sana mo sagot na.
We have two cases.
The
The first case is
wait sa the vector space B. And suppose that W maspan niya ang S. Okay? Hala. Sakto ba na yun? Then some subset of S is a basis for... okay, sige, continue. Sakto.
then and then since S is already spans W, then we conclude that S is a basis for W.
Wait, if S
Because
is
it
linearly
follows that
independent,
all it's a subset.
okay, then ang S mo spans naman siya sa W, we conclude that, okay, sige, continue. Nakuha ninyo, class? Ibalik na ng previous ni mga kuans, previous slide. Previous slide. S is be a non-zero vector. Be a set of non-zero vector in wala man dili man siya given nga kuan.
Bali, ano to sir, marag, ang isa ka case sir is independent siya daan, ang isa is dependent siya daan. So yung A is
Okay.
independent siya daan po.
Okay, case 1, ang S nimo independent. Okay, sige. Sige, continue.
Yes sir. Of course, if S is
Tangin lang ha, case 1 linearly independent.
then since
Kung case
S
one,
is
kung
already
Ay, kaning sani. Ibutang ha sa imong proof.
Yes, sir.
Case 1, S is linearly independent. Then, makaspan man siya sa W, automatic basis siya. So what? There is no problem with it. Ang problema kung ang S is linearly dependent. Okay. Utangin lang case 1 ha. Case 1, S is linearly independent. Case 2, S is linearly dependent. Okay?
yes po sir, no? Noted po sir.
Okay. Continue.
Already spans W, then we conclude that S is a basis for W
Okay.
because it follows that
Correct.
all its subsets are linearly independent as well. Another case is, of course, if S is linearly dependent, then A1 V1 plus A2 V2 plus AN Vn is equal to 0, where A1 to AN are not all 0. So this is,
Okay.
if you can remember, the theorem 4.7, that some vector Vj in S can be written as linear combination of the preceding vectors in S. That means linearly dependent. Hence, we may delete this vector from S to be in a strict smaller set of S sub 1 or S1 that
Okay.
still spans the W.
Okay.
If S1 is linearly independent, then it is a basis for W. That
Okay.
means if we get a subset that is not a basis, then we delete and then proceed. That spans W, and then check if it is a basis for W. And so,
So basically, kung sa'yo mong ginabuhat diri,
so
sir?
it is stated.
Sir Ratio.
Tayo po,
Ratio.
sir.
Ay, sani,
Sir.
by previous can be written as a linear combination of the preceding vectors. So katong ma-write as a linear combination of the preceding vectors, mo ito'y i-remove nimo. Nakuha ninyo? Nakuha nimo, sir?
Yes, sir. Yes, sir.
Okay, then, ang mabilin, kung linearly dependent, independent na to siya, basis na to siya daritso sa W. If not, naala po isa dito nga ma-write na po as a linear combination of the preceding vector. Remove na po to siya until muabot ang time nga wala na kay mga vectors dito nga ma-write as a linear combination of the preceding vectors. Okay? Mo na ipasabot ninyo until sa to we may delete this vector from S to obtain a strictly smaller set S1 that still spans W. Okay? Wala na epektuhan ang iyang pagka-spanning set. If S1 is linearly independent, spanning pagit siya, then it is a basis for W. If not, o sa imong buhaton,
Delete again, sir.
delete again. Kinsa i-delete nimo?
Linearly dependent, sir. Then find and
No.
Ay, sir.
Dili, ang linearly independent ang i-delete. Ang i-delete nimo katong express na po.
Yes, sir. Sorry.
Yeah?
Tama po, sir. Yes po, sir.
Okay, unsa kinsa i-delete nimo? Kung linearly dependent
Linear
gyapon siya,
combination, sir.
o katong linear combination sa preceding vectors. Pag delete nimo ato, mo buhaton. Delete na po ka
Say mo, sir.
until
Delete na
mo
po ang linear
until
combination.
unsay mahitabo?
Until makakita kag sir, subset na linearly independent, sir.
Okay, very good. Until sa sige ni mo delete, muabot gyud ang time nga katong tanang vectors nga imuhang nakuha is dili na ma-express as a linear combination of the preceding vectors. Therefore, by theorem 4.7, linearly independent ba to siya, which still spans W. Okay? Okay, continue. Continue.
That it is sum of the subset of S is a basis for W.
Okay.
Now, otherwise, we may apply the same procedure to delete again a vector from S1 since a single non-zero vector is linearly independent and S is a finite set. So repeating this procedure must eventually produce a basis for W. That means one of the subset of S will be the basis for W. Okay, or sum, not just one. So if S1 is linearly independent, then S1 is linearly linear combination of the preceding. Usually, since it's finite, so it will be able to find. So eventually, we'll be able to find a subset T or another subset of S that is linearly independent and at the same time spans a double. Then that one is of course a basis for double. Now the theorem 4.9 suggests the following algorithm. So this is basically how we are going to find a basis of one of the subsets of S under the vector space. So the usual case is of course the first step to suggest the basis of, we have two cases, the usual step or the usual case, and then we have the special case. So the usual case for us to find the basis of the subsets is of course we are going to start with the linear combination. So from equation A1 V1 A2 V2 A1 V1 plus A2 V2 plus AN Vn is equal to 0, which we solve for A1 A2 to AN, where these are all 0, then S is linearly independent, and this is a basis for double. So next is of course if A1, A2, that's the second step, AN are not all 0. So of course if it's already all 0, then no need to proceed for step 2. But if it is, or if it is not all 0, then proceed to step 2. So then S is linearly dependent. So one of the vectors in S, say Vj, is a linear combination of the preceding vectors in S. So we are going to delete 1, or delete Vj from S, getting the subset, another subset S1, which also spans double. And then proceed, repeat the step 1, and then using step 1 instead of S, or S1 instead of S. So again, by repeatedly deleting vectors of S, we derive a subset of S, a subset T of S that spans W and is linearly independent. Then by that, we can find now the a subset which is a basis also for W. Another case is for the special case. So this one applies for this one is applicable if we have Rm or R raised to M, or even in polynomials. So let V be equal to R raised to M more Rm, and let S
Sir, ano po ang PowerPoint sa special case na po, sir?
the procedure for finding a subset of that is also a basis for W, which span with the linear dimension. So it's associated with the homogeneous system of equation based, of course, on the equation from the step 1. And then transform it to reduced row echelon form. We could also use Gauss-Jordan from step 3. That means we are going to, the vectors correspond to the columns containing the lead. The leading ones form a basis A for W, which is also equal to spans. That means the diagonal will be equal to 1. If not all, then we are going to choose though one of the examples or X. So example 6. Say let V
Wala nag-move
equal
ang
to R
imuhang kuan.
S equal to vectors 1.
Sir, sorry po sir.
Wala kang move.
Example 6 na po sir.
Lagi ang slide mo, wala kang move. Wala kang slide para ana.
Given pa ang sir, example 6 muna na given po sir.
Lagi pero ang imong slide lagi wala nag move.
Wait lang sir.
Ha? Tama ni nga lahi po.
Hapa ka nga slide sir, sorry po sir.
Patong proof pa nga slide.
Ay sorry sir, examples about classmates, makita niya example 6 classmate.
Yes,
Example 6, sir.
Okay sir.
Okay.
Proceed na po sir.
Or V1 to V5. Or V1 is 1 0 1 V2 and procedure from the algorithm. So to proceed, first step 1, start with the linear combination. So then we get A1 times vector 1 0 1 plus A2 times the vector 2 0 1 1 plus A3 times the vector 3 1 arc 1 negative 0 wait A2 then 0 and we have A for 1 and then A5 negative 5 and then of course 0. And the next we have A1 to 0. And then the solution, but this is the output where they as a table. So 1, column 2, and then
1, 2,
column 4.
4.
So V1 for the column 1, V2 for the column 2, then V4 for the column 4. So this one now is a basis for our so this is one of the bases of R3, which again is V2 and then the vector 1 and vector 2 and the vector 4. So that's the end of my presentation.
Next, this is reporter next year. The reporter next.
Next Saturday, sir, sa advancer is ako sa Las
With our Professor Dr. Castillo. Good afternoon also to my classmates. So this is my reporter a while ago. So it is all about dimensions. So my topic assigned is from the definition 4.11, example 7, then example 8, then Matthew Canyeda will report that definition 4 when you give any suggestions and of course to correct my work. Vectors is also the number of the dimension of the given vectors. So it also the number of it also determine the number of linearly dependent vectors and the number of non-zero rows in echelon form, then the number of non-zero column or in column echelon form, and the number of bases is the number of dimension of the given vector. And in some other way, we can also determine, or we can also get the dimension or the basis and the dimension by determining the pivot in each row or in a column. So for the example number 7, the set of t squared, t and 1. So this is polynomial. This is a standard basis for P2. So the dimension for dim P2 is 3. To show this the row or form this from the definition into a matrix form. Okay, from T2, so this is if we have A3, if we are going to form it a matrix, so T squared have a pair of 1, 0, and 0. Then since our T squared is a second degree, so followed by first degree, so there is no given first degree, so 0. So the constant is also 0. For A2, we have 0 T squared, then we have 1T and 0. So we have 0 and 0. Then A3, so we have 0 T squared, so 0, then 0, then we have our constant 1, that is equal to 0. Then to show this is the given, this is a standard basis of P2 since, so we can this is the basis for this is 3. Of course, we can see the here 1 0 0, then 0 1 0, then 0 0 1. So